Hi everyone, welcome to the new video, and in today's video we are going to do some questions on relations. Okay, so this session is going to be the problem solving session. Okay, so here we have 5 questions written on the left side. On the right side we'll try to find out the solution to these questions. Okay, so let's start with number 1. Okay, so question number 1 says that we are given with the relation A relation B, and it is defined as that AB belongs to, okay, ordered pair AB belongs to the relation for all mod A less than equal to B, where A and B belongs to the real number. Okay, now what we have to do in this question here, the direction is given that we have to check for whether the relation is reflexive, symmetric, transitive, and equivalence. Okay, so we'll do it step by step. Okay, so first of all, see here what is given to me. So here it says that we are given with ARB, A relation B, if mod of A is less than equal to B for all here A, B belongs to R. Okay, so the other way to write it, this is we are given with the relation, okay, and which says that uh, A, B belongs to relation R, this relation R, and what A and B's belong to the relation are those who will satisfy this thing. Okay, so all those A and B's which will satisfy this thing are going to be the part of the relation. I hope you understand my point. So it means that this is the condition. Okay, this is the condition on the relation. Okay, so this is the condition on the relation. What is relation? Relation is a set of condition. Okay, relation is a set of condition, and if you remember, we defined relation as a relation is a subset of Cartesian product of two sets. So it means that we take all those pairs from the Cartesian product who satisfies the condition, right? So here it says that ordered pair AB belongs to the relation R if A and B is going to follow this condition. Okay, if A and B is going to follow this condition, if mod of A is less than equal to B. Okay, now we'll see first whether this relation is reflexive. Okay, so we'll start with reflexive. Okay, reflexive. Now, for relation to be reflexive, okay, what's the condition? Okay, so let's say that if we have relation R and we say that if this relation has to be reflexive, then we say that if it is defined on a set, then it must contain all the ordered pairs of the type AA for all A belongs to the real number. If I apply the condition here, because AB belongs to the real number, so if I have to make this relation reflexive, I have to make sure like the relation contains the ordered pair of the type AA. Okay, and for all A belongs to the real number. Now see here, if I say here A is less than B, right? Now let's say that here I take A 2, right? Let's say that here I take value of A 2. Okay, so if I take A2, okay, if A is 2, then what's going to happen? If A is 2 and A is equal to B, then what would happen? Then mod of 2, it's less than equal to 2. Okay, which is true, right? Why? Because mod of 2 is equal to 2. So I can say this relation is going to be reflexive, but there is one problem. If you take, okay, if you take A to be negative and A equal to B, now in this case, what would happen? Now see here, in this case, what would happen? So it implies that mod of minus 2 is less than equal to minus 2, right? Because A is equal to B. Now, mod of 2 is 2, and it is less than equal to minus 2. Now, this thing is not correct. This is not valid, right? So it means that for some cases, this relation is going to behave reflexive, but for some other cases, it's not going to behave reflexive, right? So it means that now the reflexive relation, or the condition for relation to be reflexive, it is not valid in this case. Okay, so that's why we would say that R is not, therefore R is not reflexive. Okay, I hope you understand the point. Okay, so R is not reflexive. Okay, now let's check if the relation is, this is number one, let's check the relation is symmetric, right? Symmetric. Okay, now what's the definition of symmetric relation? Okay, symmetric relation says that if your AB belongs to R, right? If your AB belongs to R, then there must be BA that also belongs to the relation R, right? If A is related to B, then there must be B related to A. That's what the symmetric relation says, okay? So let's see if this relation is symmetric, okay? Again, the main condition for this relation to the main condition for the relation, for any relation to happen, is that it must follow this condition. Okay, so here if I say here, let's say that here I take if I take here minus 2, right? And here B, I take 3. Okay, so minus 2, the mod of minus 2 is 2, and here 3. So 2 is less than equal to 3, which is true, right? But if I change it, okay, if I put here 3, if I put here 3 and here 2, so 3 is going to be less than equal to 2. Again, this is not going to be the symmetric relation. Do you understand what I'm trying to say? See here, symmetric means if your AB is in the relation, then your BA must be in the relation too. So here, let's say that here I put A equal to minus 2 and B here I took 3. So mod of minus 2 is going to be 2, which is less than equal to 3, which is fine. It means that minus 2 and 3, they are in the relation, right? But here, when I put value here, when I put B, when I put here this one, I put here what did I do here? When I put opposite, then I would say 3 minus 2, it's not going to be in relation R, right? Why? Because this is 3, mod of 3 is 3, and minus 2 as it is here. So they are, because this is not satisfying this, so this is not going to be the part of relation. So I can say here that R is not, therefore R is not symmetric. I hope you understand it, right? You can also check it other way. Let's say that here I took 2. If I took here 2, 2 is less than equal to 3, which is fine. But if here you take 3 and here 2, the other way is not correct, right? So which means that this relation is not symmetric. Okay, now we will check for transitive. Okay, transitive. Okay, so if this relation to be transitive, what does the transitive relation says? That if the transitive relation says that if A is related to B and B is related to C, then then A must be related to C, right? If these two things happen, then this thing must also happen, right? That's what the transitive says. Okay, so we can check it. Okay, so here we have A, it is less than equal to B. Okay, so for this A is less than equal to B, if it happens, then I can say that A and B are going to be in the relation, right? Similarly, if B and C are to be the part of this relation, then here I have to say B, it is less than equal to C. Mod of B, it is less than equal to C, right? Now, if both of them are in the relation, then I can say that A and C are also going to be the part of relation. Why I'm saying this? Here you can see that mod of A, it is less than B, right? And mod of B, it is less than C. So if you look at both these things, these two things are clearly telling me that mod of A, it will be less than equal to C. Why? Because mod A, it is less than equal to B, and which means that it is less than equal to mod B, and mod B, it is less than C. So I can say that mod of A is less than equal to C. Now, if this happens, now see here it happens. So it means that A and C, A is related to C, which means that it follows the condition. What condition? If it follows this condition of if AB and BC are in the relation, okay, belongs to the relation, then AC must also be in the relation. So therefore R is transitive. Okay, so here you can write this relation is your transitive. I hope you understand it. Okay, so let's go to number 2, question number 2, if it is clear to you, and we'll see what they had given us and what they are asking us to do. Okay, so all right, so question number 2, what it says. Question number 2 says that we are given with a relation, and relation is defined as that A is related to B. Now see here, A, it is related to B if mod of A minus B, it is greater than 1 by 2. Okay, for all or such that your A and B belongs to the real number. Okay, I hope you understand it. What does it mean? It means that the relation is defined as AB belongs to the relation if, okay, AB, so this relation is going to be the set of those ordered pairs AB, which is going to satisfy this thing, mod of A minus B, it is greater than 1 by 2. Okay, so this is the main thing. Okay, this is the main thing. So all A and B that is going to satisfy this thing, they are going to be the part of this relation. This is what it means. I hope you understand the interpretation of this relation. Okay, now we have to check if this relation is reflexive, symmetric, transitive, and equivalence. Okay, so let's start with number one, reflexive. Okay, reflexive. So reflexive relation says that, what is reflexive relation? Okay, if I have to apply reflexive relation here, it is going to take all those ordered pairs, because reflexive relation says that all the elements of set A are related to itself, right? So AA for all A belongs to the real number, right? So if I apply that definition here, let's see what would happen. Okay, so here I'm given with this A minus B, mod of A minus B, it must be greater than 1 by 2. Right, now here what I will do, if you put A equal to B, then what would happen? This left side would be 0, and here it's going to be 1 by 2, which is not correct. Like, why 0 is greater than 1 by 2, which is not possible, right? Which is not possible. So what does it mean? It means that R is not reflexive, right? R is not reflexive because when I try to map the elements in set A with the elements in set A that has to satisfy this condition, then uh, I didn't get any of the elements that are related to itself, right? So here it's not possible, because what I got here is that 0 is greater than 1 by 2, and which I know it is mathematically, it is wrong. It is wrong to say that 0 is greater than 1 by 2, therefore it is not reflexive. Then next we have to check if it is symmetric, right? So symmetric. Now, the definition of symmetric is that uh, symmetric says that if A is related to B, then B must be related to A, which says that if your AB are in the relation, then your BA must be in the relation too, right? This is what the symmetric relation says. Let's apply the things here. A minus B, it is greater than 1 by 2. Right? Now, see here, if A minus B, it is greater than 1 by 2, then okay, this defines that A, B belongs to the relation. But if here I say B minus A, then of course it's going to be greater than 1 by 2, because here I have modulus function, right? So it doesn't matter here A minus B or B minus A. It is, if it is greater than 1 by 2, then if mod of A minus B is greater than 1 by 2, then mod of B minus A, it is also going to be greater than 1 by 2, and which says that B, ordered pair BA, or which says that B is related to A. So A is related to B, B is related to A, which means that your R is symmetric. I hope you understand it. Right, now come to the next one. We'll check for transitive. Okay, transitive. Transitive here says that if, okay, if A, B belongs to R and BC belongs to R, then AC must also be in R. And here we are given with this thing that mod of A minus B, it is greater than 1 by 2. Right? Now, see here, what we can do here is that this says that what it says, if mod of A minus B is greater than 1 by 2, then your A, B are in the relation. Okay? And if mod of B minus C, it is greater than 1 by 2, then your B and C are in the relation, right? Your B and C are in the relation, right? What about AC? Okay, now how can we get AC here? Okay, let's say that, okay, let's take an example. Okay, again, I'm taking this A minus B. Okay, this is greater than 1 by 2. Okay, now if I take, okay, if A is 1, right, and B is 2, okay, if A is 1, B is 2, then mod of A minus B, 1 minus 2, it's still greater than 1 by 2 because it's going to be 1, right? So this is okay. If I take A, if I take A2 and B1, then again mod of A minus B, it's greater than 1 by 2 because A is 2, B is 1, so it is okay. They are going to be in the relation. But if, now see here, from here, from this thing, I can say that 1, 2 is in the relation. And from here, I can say that 2 and 1 are in the relation. Okay, so if 1, 2 is in the relation and 2, 1 is in the relation, so 1, 1 must be in the relation too. Only then this relation is said to be transitive. But see here, check for 1, 1. If I take A1, okay, if you take here A1, A1, B1, then 1 minus 1 is going to be 0, and 0 is greater than 1 by 2. Now, that's not true. So, which means that 1, 1, it is not going to be the part of this relation. Okay, so therefore, this relation is not transitive. R is not transitive. Transitive. Okay, maybe for some values of A and B, this is going to be transitive, but we just have to look for only one case, okay, that does not support this idea, okay, and if there is any case that does not support this idea, so it means that this relation is not going to be transitive. Okay, I hope this made sense to you. Okay, now let's go to the next one. The next one says that, so again, now see here, this relation is not reflexive, it is only symmetric. So of course it is not going to be equivalence relation. Why? Any relation is going to be equivalence if it is reflexive, symmetric, and transitive. Okay, so let's move to the next one. The next ones, again, we are given with a relation, and there is a condition that is put on that relation. We'll see what is it. I hope you understand what we did. Okay, if you don't understand it, just go through the video several times and think about it, and I'm sure you are going to understand it. All right. Okay, so number three says This was, what was it? This was symmetric. Next, this says that A is related to B if A minus B is divisible by n such that A, B belongs to integers and n is a fixed positive integer. Okay, and n is fixed positive integer. Okay, now see here, what does it mean? Now it says that the relation given to us is defined as A, B, okay, A, B belongs to relation R if A minus B is divisible by n. Okay, if A minus B is divisible by n, where A and B are integers and n is the fixed positive integers. Okay, so all A and B that are going to satisfy this is going to be the part of the relation. Okay, so let's start with the reflexive. Okay, reflexive. Okay, so reflexive, again, reflexive. So it says that this is going to be reflexive relation, right, for all A belongs to integers, right? Now, here, what is given? It says that A minus B, right, is divisible by n, right? Now, if okay, if A is equal to B, then this thing, it's going to be 0. Okay, if A is equal to B, now you see here A minus B is going to be 0, which is completely divisible by n. You understand what I'm trying to say? It says that all those A and B for which A minus B is divisible by n, okay, and n is a fixed positive integer, then all those A and B are going to be the part of relation. But here for reflexive, I said A is equal to B because that's what reflexive relation says, that all the elements are related to itself. Okay, so here, if A has to relate to itself, then I have to put B equal to A, and if that happens, A minus B is equal to 0, which is divisible by any number, right? So I can say here, from here, I can say R is reflexive. I hope you understand me. Okay, now check for symmetric. Okay, symmetric. Now symmetric, what's the definition of symmetric? So symmetric says that if your A, B are in the relation, then your B, A must also be in the relation. Okay, and here the main thing given to us is that A minus B, it must be divisible by n. Okay, so if A minus B, okay, if A minus B is divisible by n, now see here, A minus B is divisible by n, then B minus A is also divisible by n. Okay, let's say that, okay, I have a number, okay, I have a number 10, right? 10 is divisible by 2, right? Minus 10 it is divisible by 2 too, right? If 6 is divisible by 3, then minus 6 is also divisible by 3. So if A is divisible by n, then B minus A, okay, if A minus B is divisible by n, then B minus A is also divisible by n. I hope you understand it, right? If 100 is divisible by 10, then minus 100 is also divisible by 10, right? So means that from here, now see here, from this one, I can say that A, B are going to be the part of relation. From here, I can say B, A is going to be the part of relation. So that's what it says. If your A, B are in relation, then your B, A must be in the relation too. So R is symmetric. R is symmetric. I hope you understand it. Right? Now, let's check for the next one. Next, number 3, check for transitive. Okay, transitive. Let's start with the definition, which says that if AB is in the relation and BC is in the relation, then AC must be in the relation. Simple, right? So, come to the point. Now, it says that A minus B. Okay, A minus B is divisible by n, then AB is going to be in the relation. Fine, it is okay. Okay, and if BC has to be in the relation, then, sorry, if AB are in the relation, then A minus B is divisible by n, and if BC is in the relation, then B minus C is divisible by n. Now, if AC has to be in the relation, then A minus C has to be divisible by n, right? So, if now see here, if I add these two things, what would happen? A minus C, okay? If this is divisible by n, this is divisible by n, then of course it has to be divisible by n. You understand what I'm trying to say is that, see here, if 6 is divisible by 2, if your 4 is divisible by 2, then the addition or subtraction, their difference and their sum is also divisible by 2. Understand? So same here. So if they are divisible by n, then A minus C is also divisible by n, which says that here A and C are also in the relation. I hope you got it, right? Any other example? Let's say that here 9 is divisible by 3 and 6 is divisible by 3. Okay, you add these two numbers, 15. 15 is also divisible by 3. You subtract these two numbers, 3. It is also divisible by 3. So we are doing the same thing. Therefore, R is transitive. Now see here, R is reflexive, R is symmetric, R is transitive, which means that R is also, relation R is equivalence relation too. Why? Because any relation is said to be equivalence relation if it is reflexive, symmetric, and transitive. Okay, I hope this made the sense. So that's how you have to approach this problem. Okay, now let's move to the next one. Okay, so the next one says So the next one says that number 4, okay, number 4, what we are given with set A, and here what we have 1 2 3 so on up to 9, right? And you are given with the relation R that is defined. R is defined on R is a relation that is defined on a Cartesian product A. Okay, so it is defined from A cross A to A cross A, right? And 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 it says that, okay, here I can write if 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 A plus D is equal to B plus C, okay, because this is the condition, okay, then I can say that if this thing happens, then what does it mean? Then it means that A, B is related to C, D, right? So this is the condition given to you. It says that R is a relation that is applied on A cross A, right? On set A cross A, okay? And if all the elements that are going to be in A cross A, right? A cross A to A cross A, right? So all those elements which are going to be there and that follows the condition, this condition, then we can say that AB is related to CD. Okay, so we have to check, or sorry, we have to prove that relation is equivalence relation. Okay, so let's see what we can do about it. Okay, uh, first one is, let's check if it is reflexive. Okay, if it is reflexive. Now, for this to be reflexive, okay, for this thing to be reflexive, I know that the given condition here, it is A plus D, it is equal to B plus C, right? And if A plus D is equal to B plus C, then what does it mean? Then see here, what does it mean? It means that your AB, okay, your AB is related to CD, related to CD. I hope you agree with me, right? Okay, now can I write here? Okay, now see here, if I here, if A plus D is equal to B plus C, then AB is related to CD. Okay, now A plus B, it is equal to A plus B. Okay, there is nothing wrong in writing this because we know that A plus B is equal to B plus A, or other words, I can write A plus B is equal to B plus A, which is again true, right? Now, why I am doing this? Because if this is the condition given to us, and if it defines that this relation, okay, only those values which are going to satisfy this are going to be the part of relation, then here, using the same concept again, I can say that A, B, it is going to be related with AB, right? So from here, I can say that A, B, it's going to related with A, B. Okay, now you can see that the elements, right, the element is related to itself. If this happens, then I can say that here R is reflexive. Okay, I did nothing because this defines the relation, and here I just said that a plus b is a plus b, which is true, so I just interchanged the positions, and using the same concept here, I derived that AB is related to itself, which means that this is reflexive. Okay, now next point is come to its symmetric nature. Okay, symmetric. Okay, symmetric. The definition says that if A is related to B, then B must be related to A, right? So here, if A plus D is equal to B plus C, right? If A plus D is equal to B plus C, which says that what it says that uh, AB, it's going to be related with CD, okay? And it says that AB is related to CD, okay? This is according to what's given in the question, okay? But in symmetric, we have to prove that if AB is in the relation, then BA must also be in the relation. Okay, so now how we can do that? Okay, so here, uh, can I say, what I can do here is, here can I say, uh, A plus A plus B, right? If AB is in the relation, then BA must be in the relation too. So from here, BC, AB related to, if AB is in the relation, then BA must be in the relation too. Must be related to BA. Okay. Uh, Here, what I need to prove here is that A is related to B, then my B must be related to A, right? B must be related to A. If A is related to C, here it says, all right, A plus C. If my AB is related to R, then BA must be related to R. Then CD must be related to R, isn't it? My AB is related to CD, then CD must be related to R. So CD must be related to R. CD must be related to AB. So this is going to be CD must be related to A, and here B. Oh yes, that's true. Now see here, this is so simple, sorry. This is what it says, right? A plus D equal to B plus C. This is the main condition, right? Now see here, I'm just going to switch their places. So here, can I write D plus A, it's equal to C plus B? Yes, of course. See here, I just switch the places. Now from here, I can say that, here what I can say that, uh, C plus B is related to A plus D. Okay, C plus D. Here, from here, again, I can say that C plus B, it is related to 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 D plus A, right? C plus B, it is related to D plus A. So from here, can I say that CD, it is related with AB? Now see here, CD, it is related to AB, right? So it is symmetric. Why? Because if AB is related to CD, now see here, this thing says that, AB, it is related to CD. And if you just switch the places, right, then it says CD is related to AB, okay, which means that this relation R is symmetric, right? Symmetric. Okay, here you just have to find the right combinations. Okay, now let's check for transitive. Okay, transitive. Now transitive, we know that if it says that if AB belongs to R, BC and BC belongs to R, then AC must be there in R2, right? So the given condition is A plus D equal to B plus C, right? So it says that if AB is in relation with CD, okay? It says that AB is in relation with CD, right? And right, CD and can I write here? Can I write here C now see here, this is related to this. So here, if I say CD is related to EF, now how that thing is going to be possible? CD, so here D and here E and here F. So C is related to D and E is related to F. Okay,